All right, now we're going to start factoring trinomials where instead of the leading coefficient being a 1, we are going to have a coefficient in front of the x squared term. So here's an example, 4x squared plus 3x minus 10. We're just going to do 3 examples today. The first thing we're always going to do when there is a leading coefficient is we're going to check for a greatest common factor. Because if there ever is a greatest common factor, your first step always needs to be to factor that out first. And then it creates something a little bit more simpler to work with inside. So in this case, we're looking at our coefficients for 3 and negative 10, and we know right away that there is no common factor between those 3 numbers. And then we can see 2 of the terms have an x, but the third term does not, so we can't factor out a variable. So we're just kind of stuck. No greatest common factor this time, that's fine. So what we're used to working with is we're used to working with trinomials where there is no leading coefficient. So when there is a leading coefficient, now we're going to take that leading coefficient and we're going to slide to the back. All right, the reason why we're going to do that is because we don't want that there. We've already practiced factoring trinomials where it's not there, so we're just going to get rid of it. And when we slide it to the back, we're going to multiply. So now what we have is x squared plus 3x minus 40. So what I did is I took that 4 and I multiplied it by the 10, and now I have a minus 40 back there. All right, so from there, now we have a simpler trinomial that you're used to factoring. So let's factor it just like you're used to. So we know it's going to create 2 binomials, or we think it will at least. There's no number out in front now, so we can go ahead and put our x and our x. To get your signs, to know whether it's plus and plus, minus, minus, or one of each, you always look to the back. There's a minus sign back there, so that means it's going to be one of each. We're going to have one positive number and one negative number. So if they multiply to get negative 40. So now we're looking for 2 numbers that multiply to get negative 40 and add to positive 3. So let's think about the factors of 40. We've got 1 and 40, 2 and 20, 3 doesn't go into 40, we have 4 and 10, we have 5 and 8, and that's going to be our winner. We want it to be a positive 8 and a negative 5 because when we add them, it needs to get to a positive 3, so our bigger number needed to be positive. All right, so that's the steps that we're used to. But because in the beginning we just kind of got rid of that 4 by multiplying it to the back, now we have to undo that step. And in math, to undo multiplication, we divide. So now we're going to go back and we're going to divide the 2 factors that we got by what we multiplied by in the beginning. So because we multiplied by a 4, now we undo it by dividing them by 4. All right, from here, we're going to look at those 2 terms, and we're going to see if they can be reduced. So 8 over 4, that can be reduced. 8 divided by 4 is 2. 5 over 4, that cannot be reduced, and it doesn't divide evenly. So from here, we're going to do what we call bottoms up. This is actually called the bottoms up method of factoring, and here's where it gets its name. When you have a fraction that cannot be reduced anymore, and it can't divide evenly, we're going to take that bottom and we're going to move it up front. So our second binomial is going to say 4x minus 5. All right, and remember, you can always check your work by seeing if when you FOIL, you get what you started with. So in this case, if we take x times 4x, we do get 4x squared. And when we multiply the outsides, x times negative 5 is negative 5x, 2 times 4x is 8x. So when we add those together, we get 3x. And when we multiply the last ones, 2 times negative 5, we do get negative 10. So it worked when we FOILed it all out. Come on. We're going to walk a little bit quicker through our next 2 examples, but if you ever need to see what that step is that I did, make sure you watch that first example again. So here we have another example where we have a leading coefficient, and we haven't been used to dealing with those. So first, we always check for a greatest common factor. In this case, there is not one. There's not a factor between, or a common factor between 6, 11, and 3. So we're going to get rid of that 6 by sliding it to the back and multiplying it by 3. So we're going to get x squared plus 11x plus 18. So this is what our normal factoring has been. We're going to set up our 2 parentheses for factoring it into 2 binomials. We have an x squared in front, so x and x. we have a plus sign in the back, which means they're going to be the same sign. In this case, they're both going to be positive. We're looking for two numbers that multiply to give us 18 and add to get 11. Those would be 2 and 9. And now, because we multiplied in the beginning, now we have to undo that step. So to undo that beginning step, we're going to divide them both by 6. And now we've hit the point where we have to reduce our fractions if we can. So 2, we know we can't divide that by 6, but we can reduce that fraction. It's really important that you remember to reduce the fractions if you can, because if you don't reduce your fractions, you're not going to be able to FOIL that and get what we started with. So 2 over 6, both of those numbers are divisible by 2, so we can reduce that to 1/3. And usually if you can reduce one fraction, you can reduce the other. So 9 over 6 can also be reduced. They're both divisible by 3, so we get 3 over 2. So now we've reduced our fractions, but we don't want fractions in our final answer, so what we still need to do is use the bottoms up. So that's when we take the bottom and we move it up front. So our final answer is going to be 3x plus 1 and 2x plus 3. And again, I will encourage you to go ahead and check at least your first terms. Make sure you get 6x squared, and your last terms, make sure you get 3. So at least check that part, and then to be safe, you can always check your middle to make sure that by multiplying the outsides and the insides, we get the 11x. All right, our last example for today, we have another trinomial where we have a leading coefficient, so don't forget that your final step, is to factor out a GCF. So check at those three terms. We've got a 6, we've got a 33, and we've got a 45. So greatest common factor in this case, we do have one. They all have a common factor of 3. So before we want to do anything else, we want to factor out that greatest common factor of 3. So to do that, we always put our greatest common factor out in front, and then we're just going to be dividing each of these terms by 3. All right, so here we're left with 2x squared. Here we get negative 11x, and finally we get a positive 15 in the back. So we were able to factor out a GCF, and it made the trinomial that we're left with a little bit simpler to work with, but we still have a leading coefficient inside there. Now we're just going to kind of ignore that 3 for a little bit. It's part of our factor. It's one of our factors of this original trinomial, but we're going to kind of ignore it and just work it within the parentheses for a little bit. This still has to be part of your final answer, but we're just going to ignore it. So next, we still have this coefficient out in front, so we're going to slide it to the back. And when we slide, we're going to multiply that. So then we get x squared minus 11x plus 30 now in the back. So from here, these are the steps that we're good at. We're going to set up our parentheses. Now there is no longer a leading coefficient. Remember that 3 is still out there, but we're going to ignore it. So we have x and x. Plus sign in the back means they're going to be the same sign. It's either going to be plus plus or minus minus. Here we look and see that it's going to be minus minus. So now we're looking for two numbers that multiply to get 30 and add to get 11. And those are 5 and 6, or 6 and 5. All right, now here's where you need to be a little bit more careful. We still have to divide by what we multiplied by in the beginning, but don't look up here. We didn't slide a 6 to the back. We slid a 2 to the back. So whatever you multiply by, whatever you slide, now we have to divide. So we slid a 2, so now we're going to divide by 2. 5 over 2, that doesn't come out even, and it can't be reduced. 6 over 2, that can't be reduced, but we know 6 over 2 is just 3, so we're going to leave that x minus 3. And here, because it couldn't be reduced, we're going to take that denominator, bottoms up, 2x minus 5. Don't forget your greatest common factor, because after you FOIL the parentheses, you would have to multiply everything then by 3 to get our original expression. That's all.